Howdy, howdy, everybody. It's Mrs. Mazzola, ready for our second round of math lessons today. But first, our joke. This lesson is going to be on symmetry for shapes. So we're going to have a math joke related to that. Here we go. Where are mathematicians buried? The symmetry. The symmetry. Oh my gosh, that's so funny. Anyway, down to our math. So with our lesson today, we're looking at symmetry of polygons. And before we can look at what that means, is we have to do some vocabulary terms, just like the last time. So if you need to, pause the video here, grab a piece of paper or your notebook that you've been taking notes in, and you might want to write some of these terms down to help you with symmetry. And there's less vocab terms in this lesson than there was in the previous one, so don't worry. All right, so looking at symmetry of polygons, we have to kind of break down what this means first. So the first term that we're looking at is line of symmetry. When we're talking about symmetry, usually there is a line of symmetry. And what that means is a line of symmetry is when parts of a shape are identical. I got a little squish. Let's try that again. Parts of a shape are identical or the same. And you might want to put that in parentheses by that word. Same is what identical means. On both sides of the line. Or they are a mirror. We can also think of it like a mirror image. Okay, so we're going to draw a couple of examples and non-examples for these terms because it's kind of hard to tell the difference sometimes. So first, if we have a shape that looks something like this, and you're going to have to use your imagination a little bit. You have to pretend that they're like perfect shapes, not Mrs. Mazzola's beautiful artistic drawings type shapes. And with lines of symmetry, you have to use a little bit of your math imagination brain to be able to kind of visualize things. So when we do lines of symmetry, what that means is we're taking lines and we are splitting the shape in pieces. And we're trying to see if it's identical on either side of the line. So for example, don't draw this one. This one's an example. If we were going to draw a line through our shape like that, through our heart, that one wouldn't be identical if we were to look at it. It's got a V shape on this side and two lumps on the other side of our line. So that one wouldn't be identical, but we have another spot where we might be able to split it. So this is the one where you're going to draw and take a look. If we have a line going through our shape, and a lot of times they're dotted lines. So otherwise, if we add a line to it, it makes it a little bit different. If we put a dotted line right there on this shape, if we look at both sides, they are the same shape. And one way that we would test this too, you kind of have to do it in your brain, is you have to think about folding that piece over. So if I were to take this piece and fold it over my line, just like if I had this as a piece of paper, okay? If I were going to take my heart-shaped piece of paper and I were to fold it over, would it be the exact same shape once I folded it over? And that's what you have to think about with lines of symmetry. So if I did it with this heart, yes, that one would be a line of symmetry. Okay, it would be the exact same on either side. But an example that would not be, so this one would not be an example of a line of symmetry. And I'm going to show you how. If we have a parallelogram that looks like this, bear with me on the shapes, and we were to draw our line going like this through our shape. Okay, you might think, well, they kind of look the same. They've got, a point like that and a point like that. But if I were to take this as a piece of paper, imagine folding it over. This corner would go over here. This would go over here. And if you look, it's slanted sideways. So if I were going to take this corner and fold it over to that side, it would pass over it because this far side is slouched. It's pushed over. So for this one would not be a line of symmetry. So you might want to draw this one as a non-example with a line through it. It doesn't work that way. It's not exactly the same on either side of the line if I were to fold them and make them meet. Okay, so that is a line of symmetry. That red line that we've drawn that splits a shape is a line of symmetry. And some shapes have more than one line. Some of them have none, like we looked at with that second example. So just keeping that in mind as we go along. So the second thing we need to know is what a polygon is. If we're trying to do symmetry of polygons, we got to know what a polygon is. So a polygon is any closed shape. And this is a term that you may know already. You may have heard about polygons before, and specifically in third grade. This is just any closed shape. What that means is that you've drawn the lines or whatever it takes for your shape, and they finish and meet up. So we're going to draw some examples of actual polygons and non-examples of polygons so that you know the difference and know what the difference between closed and open means. So we're going to do some very basic polygons that I'm sure you're all going to recognize. Here is a polygon. Gee, I wonder what that one is called. And we have another polygon and a third polygon. Boy, we see that one like every day driving around with mom and dad. Okay, those are all polygons because if you look at these shapes, they are closed. There's no gaps anywhere along these shapes. And even with my pen, you know, there might look like there's some gaps like this one. I didn't intend for there to be space between those. It's really hard with the pen to connect them all. Anyway, if you look at those connections all through there, there's nothing missing. There's no gaps. They all connect and they close at the end. So some examples of not polygons would look like this. And you see, I know you guys will all know this one because you all draw it all the time. That. If you look at this one, it starts here and ends here, and they don't connect up. They're not closed at all. Even if I drew a line that went like this, it still wouldn't close it because look, I've got open space on the inside, okay? So this one is a non-closed shape. So this one would be a non-example of a polygon. It's not one. And another one that tricks a lot of people a lot of times looks like this. You're like, but wait, Ms. Mazzola, I know where that's going. I know what it kind of looks like. It's kind of going like that one, but it's not. This is where my pencil stopped and I have to decide whether it's a polygon. So if I look right here, there's a gap in my shape. So it's not actually a shape, it's a line. So it has to be closed. It has to connect and be finished to be a polygon, okay? So we can't do lines of symmetry on something like this. On this last one that's a non-example. We can't do lines of symmetry on that because it's not a polygon. So for us today, we only want polygons and finished shapes. Okay, so let's take a look at a couple of them and put on your math brain and your imagination cap because you're going to need it to be able to think about folding these shapes. Do they match up when I imagine them in my head folding them? Okay, all right, so here's our first two. Let's take a look at this T first. So what I like to do kind of in my head is I imagine drawing these lines and chopping these shapes apart to see if they would be the same. So maybe I take my first thought and I chop it right there. Well, if I think about that, I've got a rectangle up here and then I've got a rectangle going that direction. If I fold those two, they are not going to line up. So that one doesn't work. Even if I move it down here, it doesn't solve my problem. I can think about maybe diagonals if I split like that, but then even drawing my diagonal line, I can see, well, there's way more shape on this side than there is on the other side of my diagonal. So that one doesn't work. And since this T is a perfect T, if this one doesn't work, that one's not going to work either. So my last spot is to try to split it exactly down the middle. So if I were to split this shape exactly down the middle, and you're going to have to bear with me, remember my straight lines, I might even be able to fix that. Let's see. I think I might be able to. There we go. Okay. My lines can split it in half. And if I look at that, if it's exactly in the middle, which mine's kind of a little bit wonky off, but I can see that I've got a shape kind of like that on this side. And if I look at the other side, it's the same thing. And if I picture folding that over, this corner is going to go lay exactly on that corner. This corner will lay exactly on that corner. This corner to this corner, this line's gonna lay right there, okay? It's all gonna match up. It's all gonna be the same. It's like folding my Post-it note in half. They're all gonna line up, okay? But it didn't work anywhere else. So for this one, for this shape, there was only one line of symmetry. Okay, and there may be more on other shapes. You kind of have to test it out. So let's take a look at our next shape. This one kind of looks like a dog bone or a dog toy, in my opinion. So we're going to kind of use my tester theory. I'm just going to kind of draw some lines here. If I were going to draw maybe diagonal, I can kind of visualize with that, like, ooh, those don't look the same. It's got like a little nub in here, but a big nub in there. That doesn't work. So what about if I go like that? No, if I chop it right there, this piece is bigger than that piece. They're kind of the same shape, but not the same size. So maybe let me try splitting it down the middle. If my shape were actually turned the right direction, if I were to imagine, and I'll show you guys what you would imagine in your heads, if I were to turn this sideways like that, then I might be able to see that middle point a little bit easier. So I'll take my line and split it exactly down the middle. Let's try to get that straight line again. Poof. There we go. Okay, now if I look at my shape that I split it into now, this section and this section should be the same. This and this should be the same. And if I think about folding it over onto the other one, it should lay flat exactly on it. And it actually works if I were to picture this in my head. But there might be another option. So if I think about the other ones that I tried some of those diagonals, but there's another half split that I could try on this one. So if I draw my other half split right there, and I take a look at my shape, it's the same on both sides. If I were to fold it long ways or hot dog style, it would still line up and it would still work. So all those other ones that I tried didn't work, but these two lines did. So this shape has two lines of symmetry. It has two spots where you can split that shape and it's going to be identical or the same on either side of those shapes. Okay, and let's look at our last one. This one might be a little bit tricky for some of you. So if I were to take my tester and start drawing some lines, I might start with my diagonals because I seem to like starting with those for some reason. And I split it like that and I go, oh, well, that looks like it's right. Let me try that again. Yeah, it looks like it's the same shape on that side. So I'm going to go ahead and draw that line. So now I do have a line of symmetry right there in my diagonal. This is the same as this. And if I folded it, this looks like a Post-it note turned sideways. So I guess that works. So what about my other diagonal? Do you think my other one would work? If I take a look at that, it's the same shape again. So I have another line of symmetry that works right there. Okay, so it splits through the other side. But then I liked to try the like middle splits. After my diagonals either worked or didn't, I like to try my middle splits. So let's take a look at that one. If I imagine in my head going right down the middle, this split down the middle, looks the same to me. We got another one. So we'll draw our line down the middle there. That one was way off, Mrs. Mazzola. There we go. That's well, y'all are better at drawing that. That one's a little bit closer. Anyway, you can picture it. Okay, so now we've got our last middle split. We got to visualize right there. Is it the same here and here if I split it like that? You got it. It is the same. So I've got another line of symmetry. So I want to draw that last line right there. Nope. There we go. And now I've got those lines of symmetry. And I could test out some more, like if I were to draw like that. Those kind of look the same, but when I fold them, they're not going to be the same. So let's do that one as an example kind of for your brain. So if I were to split it right there, I've got that shape and that shape. So it's not even the same. If I were to take this piece and fold it over the line, I'd have a little kinked out spot like this, and it wouldn't line up with the shape that's underneath. So that line wouldn't work. And I could go around the whole shape trying out things like that. But I have found the end of my amount of lines of symmetry. So for this shape, you have to be careful when you count around in a circle because you have to actually count the lines you drew, not how many ends you see here. If you do that, you're going to end up getting double because these lines have two different points. So it's the amount of lines that you drew for your shape. So if we were to count them, we had 1, 2, 3, 4 lines that we drew. So this shape has 4 lines of symmetry. So what you want to make sure about with lines of symmetry that you don't get tricked about is making sure you've tested either in your brain or on the paper if you've got all of your lines. I could have stopped at 2 on this one and thought, oh, I've got 2 lines of symmetry. Well, that's enough. But it wouldn't be all of them, as we found out. You have to try to find all of the possible lines of symmetry that a shape has to be correct. Unless you're being asked to draw just one example, then you would only have to pick one of these to draw. But if it's asking you how many lines of symmetry, you got to know how many there are completely, not just how many you decided you wanted to draw that day. Okay. So don't forget that your symmetry has to be identical. That very important word, identical or the same on both sides of the line you draw. Think about folding that shape in half. Is it going to line up on both sides where you folded it? Okay. So good luck with your assignment. Let me know if you have any questions. Good luck, mathematicians.